Google can now read your entire digital life, every email, photo, search, and YouTube video to answer questions you haven't even asked yet.
Wait, they're doing this automatically? Like Gemini is just analyzing everything we've ever done online without us asking?
It's called personal intelligence, and it's rolling out in beta right now. If you've used Gmail or Google Photos in the last decade, this AI already knows more about you than your closest friends, and it's about to start using that knowledge.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into Gemini's new beta feature provides proactive responses based on your photos, emails, and more.
But first, let's cover today's top headlines.
There's a fascinating new development from AWS about securing Amazon Bedrock's cross-region inference profiles. They've published a comprehensive guide on how to distribute AI inference processing across multiple regions for better reliability and throughput.
Cross-region inference? That sounds like it could really help with latency issues for global applications.
Exactly. The AWS machine learning blog details how CRIS profiles can help organizations maintain security while scaling their AI workloads globally. It's particularly relevant for companies dealing with data sovereignty requirements.
Speaking of AI safety, there's intriguing research from Archive about improving large language model safety through case-based reasoning. The paper introduces something called CADA, Case-Augmented Deliberative Alignment.
So instead of just hard-coding safety rules, they're using precedents?
Right, like a legal system. The researchers argue that using real-world cases alongside explicit rules creates more nuanced and effective safety guardrails for LLMs.
Shifting to practical applications, OpenAI just shared how Zenken, a Japanese company, transformed their sales operations with ChatGPT Enterprise. They're reporting massive time savings and cost reductions.
The case study mentions they've significantly improved their international communication capabilities, too. That's a huge deal for Japanese companies looking to expand globally.
In the research world, there's new work on contextual reinforcement learning from Archive. The paper introduces SDMBTL, Structure Detection Model-Based Transfer Learning.
That's a mouthful. What's the breakthrough here?
It dynamically identifies generalization structures in contextual Markov decision processes. Basically, it helps AI systems better understand when and how to apply learned behaviors in different contexts.
And finally, some exciting news for developers. Cursor, the AI-powered code editor, just introduced dynamic context discovery.
InfoQ reports this new feature dramatically improves token efficiency when working with large language models. Instead of sending entire code bases, it intelligently retrieves only the necessary context.
That could mean significant cost savings for development teams using AI assistance.
That covers today's headlines. Now let's get into our main story. So, Google just dropped something that's either brilliant or terrifying, depending on how you look at it. Gemini's new beta feature is essentially reading your entire digital life, photos, emails, calendar, everything, and proactively suggesting actions before you even asked.
Wait, proactively? Like it's just watching everything and jumping in with suggestions?
Exactly. Picture this. You take a photo of a concert poster, and Gemini immediately suggests adding it to your calendar, finding tickets, even coordinating with friends who might be interested based on your past emails.
That's incredibly powerful, but also the privacy implications here are massive, right?
That's the core tension. Google's calling it contextual awareness, but what they've really built is an AI that's constantly analyzing every piece of data you generate. The technical achievement is impressive. They're processing multimodal inputs in real time, cross-referencing against your personal data graph, and generating relevant suggestions within seconds.
How are they even doing that at scale? The compute requirements alone must be astronomical.
They're leveraging their tensor processing units in a really clever way. From what we can tell, they're doing edge pre-processing on device for basic categorization, then sending compressed feature vectors to their cloud infrastructure for the heavy lifting. It's not running the full Gemini model on every photo. That would be insane.
So it's like a tiered approach. Local inference for privacy-sensitive stuff, cloud for complex reasoning?
Exactly. And here's where it gets interesting for platform engineers. They've built this abstraction layer they're calling context mesh. It's essentially a unified API that lets Gemini access different data sources while maintaining some semblance of access control. Think of it as GraphQL for your personal data.
That actually sounds like something we could learn from for our own systems. How granular is the permission model?
From the beta documentation, it looks like they've got 3 levels. Basic awareness, which just knows what apps you have, interactive awareness, which can read but not write, and full agency, which can actually take actions on your behalf. Users can set these permissions per app, per data type.
But the default settings are probably going to be pretty permissive, right? Most users won't dig into those controls.
You're absolutely right, and that's the concerning part. The feature is opt-in for the beta, but Google's track record suggests this will eventually become opt-out, if not mandatory for certain services. Coming up, we'll dig into exactly how they're pulling this off technically and what it means for the future of AI assistants.
So let's get into the technical meat here. How is Gemini actually processing all this disparate data in real time?
The architecture is fascinating. They're using what they call continuous context windows. Basically, instead of processing each interaction in isolation, Gemini maintains a rolling 72-hour context of your digital activity. Every photo, email, calendar event, and search query gets vectorized and stored in a high-performance graph database.
Oh, so it's not just looking at individual items, it's understanding relationships between them.
Exactly. Here's a concrete example. Say you receive an email about a flight delay. Traditional systems would just flag that. Gemini's approach connects that to your calendar, realizes you have a meeting scheduled after landing, checks traffic patterns for that time, and proactively suggests rescheduling the meeting and ordering an Uber to go straight there instead of your hotel.
That's actually incredibly useful. What kind of latency are they achieving?
Beta testers are reporting sub-200 millisecond response times for simple suggestions, up to 2 to 3 seconds for complex multi-step reasoning. They're achieving this through aggressive caching and predictive prefetching. The system actually pre-computes likely scenarios based on your patterns.
That must be eating up storage like crazy. How much data are we talking about per user?
Based on some back-of-envelope calculations from the API limits they've published, we're looking at roughly 50 to 100 gigabytes per active user when you factor in embeddings, cached computations, and relationship graphs. But here's the kicker. They're using a technique called semantic compression, where similar patterns get deduplicated at the embedding level.
How does that work in practice?
So instead of storing every meeting reminder email separately, they create a canonical representation and just store the deltas. It's like Git for your personal data. They claim this reduces storage requirements by 60 to 70% for typical users.
But what about data freshness? If they're caching so aggressively, how do they handle updates?
They've implemented this clever invalidation strategy using what they call cascade triggers. When one piece of data changes, it propagates updates only to related nodes in the graph. So changing a flight doesn't recompute your entire schedule, just the affected time windows and related events.
This is starting to sound like the kind of event-driven architecture we've been trying to build for our own systems.
Right? The patterns are definitely applicable beyond just AI assistants. They're essentially solving distributed state management at a massive scale. The real innovation is in how they're handling privacy boundaries within the system.
How so?
Each data source maintains its own encryption keys, and Gemini never actually stores the raw data, only the embeddings and relationships. So even if someone compromised the system, they'd get mathematical representations, not your actual emails or photos.
That's clever, but couldn't you potentially reverse engineer content from embeddings?
That's the million-dollar question. Google claims their embedding process is one way, but researchers have shown you can extract surprising amounts of information from embeddings if you have enough examples. It's not perfect recreation, but it might be enough to infer sensitive information.
So we're trading convenience for a new kind of privacy risk.
Exactly. And the scariest part? This is just the beginning. Stick around. We'll break down exactly what this means for you and how to navigate this new world of proactive AI. So, here's what platform engineers need to understand about this shift. We're moving from reactive to proactive systems, and that changes everything about how we design architectures.
What's the biggest takeaway for teams building their own AI features?
First, start thinking in terms of continuous context, not discrete interactions. Traditional request-response patterns don't work when your system needs to maintain awareness across time. You need event streaming, state management, and, most importantly, a way to query historical patterns.
So like Kafka or Pulsar for the event bus, maybe ClickHouse for time series analysis.
You're on the right track, but here's the key insight from Gemini's approach. They're not just storing events, they're continuously computing relationships. Think graph database meets stream processing. Neo4j announced they're working on something similar called temporal graphs, specifically because of demands like this.
That makes sense. What about the privacy architecture? How do we build these systems responsibly?
3 critical principles. First, data minimization. Only compute and store what you absolutely need. Gemini might be going overboard here, but you don't have to. Second, user control. Not just on-off switches, but granular controls over what data gets processed and how. Third, audit trails. Users should be able to see exactly what decisions were made using their data.
That last one sounds like it could get complex fast.
It is, but it's non-negotiable. Here's a practical framework. Implement a decision log that records not just what action was taken, but what data points influenced it. Storage is cheap compared to losing user trust. Make it queryable, make it exportable, and make it understandable to non-technical users.
What about the competitive landscape? Is everyone going to rush to copy this?
Microsoft's already working on something similar with Copilot, but they're taking a more conservative approach, keeping processing local where possible. Apple's likely to announce something at WWDC that emphasizes on-device intelligence. The real question is whether users actually want this level of proactive assistance.
Do they, though? It feels like we might be solving problems people don't actually have.
That's the billion-dollar question. Early beta feedback suggests power users love it, saving 30 to 45 minutes per day on routine tasks. But there's a real risk of creepy valley, where the AI knows too much and users feel surveilled rather than supported.
So what should teams do right now?
3 things. First, experiment with context-aware features in a limited scope, maybe just within your app, not across the entire digital life. Second, invest in privacy-preserving ML techniques like federated learning and differential privacy. They're not perfect, but they're better than nothing. Third, start building user trust now through transparency.
Any specific tools or frameworks you'd recommend?
For experimentation, check out LangChain's new memory modules. They're implementing similar patterns. For privacy, Google's own privacy sandbox tools are actually quite good, ironically. And for trust, implement something like Apple's privacy nutrition labels, but for AI features.
This feels like a fundamental shift in how we think about software.
It really is. We're moving from tools that wait for commands to partners that anticipate needs. The technical challenges are solvable. We've covered the key patterns today. The real challenge is doing it in a way that empowers users rather than exploiting them.
And if we don't get it right?
Then we risk a massive backlash that could set the entire industry back years. But if we do get it right, if we build these systems with privacy, transparency, and user control at the core, we could genuinely transform how people interact with technology.
No pressure, right?
The best time to start thinking about this was yesterday. The second best time is now. Whether you're building the next Gemini or just adding AI to your existing product, these patterns and principles will define the next decade of software development. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.